Hello, everyone. I am very happy to present our work, From Pairs to Sequences, Trackaware Policy Gradients for Keypoint Detection or TrackPoint. The key message of this talk is simple. Local features should not only match well between two images, they should also build reliable tracks across a sequence. Most keypoint detectors are still trained with image pairs. This is natural for many benchmarks, but it does not fully match how local features are used in real applications. In SFM, SLAM, visual odometry, and localization, we do not use just one image pair. We use a sequence of images, and we need landmarks that can survive across many views. This creates a gap. A keypoint may be matchable in one pair, but it can drift, disappear, or become ambiguous after viewpoint change, occlusion, or motion. So the real requirement is not only pairwise matchability. What we need is long-term trackability. A good keypoint should remain stable and distinctive over multiple frames. Our idea is to directly optimize keypoints from a sequence-level view. Instead of asking whether a point is good for one pair, we ask whether this point can form a good track across the sequence. In other words, a keypoint is treated as a decision, and this decision is evaluated by the quality of the track it produces. To implement this idea, we introduce TrackPoint, a sequence-aware reinforcement learning framework. The pipeline is as follows. We choose a reference frame, sample keypoints from the detector, track or project these points through the sequence, compute a trackability reward, and then use this reward to update the detector. In the reinforcement learning formulation, the state is the reference image, the action is the selected keypoints, the environment is the following sequence, and the reward is the quality of the resulting tracks. During inference, the model is still a standard feed-forward keypoint detector, so the sequence-level training does not introduce extra test time optimization. For the architecture, we use a describe-then-detect design. A descriptor branch is first trained and then frozen. This frozen descriptor provides a stable feature space for reward computation. The detector branch is then learned as the policy network, which decides where keypoints should be placed. For action sampling, we use a hybrid strategy. Global sampling focuses on high-confidence regions, while grid sampling preserves spatial coverage. This prevents the detector from collapsing into only a few textured areas, and it gives us a better balance between reliability and diversity. Now I will briefly explain the reward. For each sampled keypoint, we project it into target frames using the available geometry, and only visible frames are used for reward computation. If the point is never visible, its reward is 0. The reward has two parts. The first is a ranking reward, which asks whether the point remains locally salient after projection. It does not need to be the strongest point everywhere, but it should stay highly ranked in its neighborhood across views. The second is a distinctiveness reward, which asks whether the descriptor is unique enough and not easily confused with other locations. We combine these two terms and average them over visible frames. Then policy gradient increases the probability of high reward points and suppresses low reward points. In this way, the detector gradually learns to prefer points that are both stable and distinctive across a sequence. We evaluate TrackPoint on both pairwise and sequence-level tasks. On megadepth relative pose estimation, TrackPoint still performs well on the traditional pairwise setting, showing that sequence-aware training does not hurt pairwise matching. On Kitty visual odometry, our keypoints produce longer and more stable tracks, which leads to more reliable trajectory estimation. On ETH multi-view reconstruction, more selected keypoints become successful 3D landmarks, showing that our method improves the reliability of points for downstream geometry. To summarize, TrackPoint shifts keypoint learning from matching image pairs to building reliable tracks. By using trackaware rewards and policy gradients, we learn keypoints that are stable, distinctive, and more useful for sequence-based downstream tasks. Thank you.